All right, I want to be a perfectionist. I want to make sure everything on my plans look great. I want to make sure that every single thing I have checked and double checked. There is no way any comment could possibly come up out of this. The red lines are perfect. The blue lines are perfect. The design is perfect. Everything on my plans is exactly the way it should be. And yet, when it comes back from the reviewer, there's red lines, there's comments, there's all kinds of red lines all over the plans. And why is that? I spent so much time in trying to make sure that I would not get a single comment on my plans. Is that the right way to go about doing engineering? Is that the right way to look at engineering? When we are doing our designs, are we really trying to be perfect, or are we trying to be engineers? We'll talk about that in this video. In engineering, there is such a law as diminishing returns. As we can put in more and more effort to try to make sure that our designs are exactly right, that they are perfect the first time they go out, that there is no mistakes, no errors, no anything on those plans, that the design is the ideal design, and that there's no other design possible that could outdo your design. Well, is that really true? In engineering, are we asked to be perfect in our designs, or are we asked to do a quality design that gets the results done? Will our design meet the criteria of the agency that review it and also the criteria of the client? Does it meet those standards? Does it meet the accepted practice of engineering? That is the question that we all have to face when we're looking at doing engineering designs. As a project engineer, you must decide how much time you're going to spend on your designs, because doing too much will blow your budgets, and doing too much gets to the law of diminishing returns. Early on in my project engineering career, I learned very quickly that I could spend all night reviewing plans, coming up with different ideas, trying to figure out the best one. But I learned that over time, by experience, I kind of knew what the answer would be. I knew that if I'm going to go from one manhole to the next manhole with a pipe, let's say a sewer pipe, that if there has a certain quantity of water or sewage going through it, it has to be a certain size pipe. It has to have a certain slope, a minimum slope and a maximum slope. As long as it fell within those two criteria, and I have my manhole depths at about 10 feet deep for a sewer or less, 6 feet to 10 feet, then I'm in that sweet zone. I've done my job as an engineer. Now, I could spend hours and hours and hours and now more hours, even days, trying to get at the exactly perfect alignment of that manhole, so those two manholes and that pipe that runs through it, to get exactly the right size and exactly the right amount of flow and exactly the right amount of velocity. But is it necessary? Well, the answer is generally no. And so what we have to do as engineers is realize that what we are trying to do is engineer a project to be able to get it to where it's done quickly, meet those standards, meet the criteria, and so that we can get the final product to our client as quickly as possible so he can build it in the field. I know you've been getting value out of this video, so please go down below right there and click that subscribe button. Also go over to the side over there and ring that bell so that you'll be notified every time we upload a new video. All of our videos are short and concise, and they're specifically on project engineering and project managing. So as engineers, all of our designs, they have what we call a factor of safety. When we do a hydrology analysis, we have to understand that the models that we're using have a great deal of factor of safety in it. When we say the flow that's generated from a site from rainfall after a 6-hour rainfall, you notice it's always in a whole number. It's never in tenths of a cubic foot per second or 100 cubic foot per second. It's always in a whole number. 20 CFS, 5 CFS, 100 CFS, 1,000 CFS, but never down to those decimal points, because that's a factor of safety that we're dealing with. When we're designing dams, you notice that the dams that we build are to the a Category 4 hurricane or to a Category 5 hurricane. Could there be a hurricane that's greater than that? Sure. And if it does, well, it overtops the levee, And so, but those are so small, so rare, and the cost to build something like that would be enormous, and it wouldn't be used very often. So quite often what we do in hydrology and hydraulic designs in the field is that we design to what used to be called the 100-year storms. Now we call it the 1% chance storm within a year. So that means if something was, say, a 0.5% chance of rainfall that could come by, well, it would exceed our limits and our structures and our designs would fail. So you can see right there, our designs aren't perfect. They're engineered to meet a certain standard and criteria in our designs. If you're trying to make a perfect design that meets everything and it's just ideal situations, well, it takes a lot of time to do that. And if you're spending a lot of time to design, you're more than likely are spending the budget and you're exceeding your timelines. So it's more important that you find somewhere in between, that you're engineering this project, that you're trying to make sure it meets the standards, the criteria of your client and the government reviewing agencies. So what is the best way to destroy perfectionism in engineering? Well, there's two. One is your experience level. How many years have you been working as an engineer and designing? The longer your design experience is, well, the more you've seen and the more you've experienced, the chances are you can come up with a design pretty quickly to solve the problem. Also is your knowledge base. Even after college, you will continue to grow your knowledge in your profession, especially the area that you're practicing in as an engineer. The more knowledge that you have, it gives you the broader base to be able to answer any kind of question that may come up in your profession, no matter what it is in engineering, whether you're a computer engineer, a structural engineer, a chemical engineer, whatever kind of engineer you are. It's your knowledge base and your experience. That's what keeps you from going that perfectionism route and staying as an engineer. Meeting criteria, meeting standards, and meeting your client's requirements. That's the key. So don't be a perfectionist, be an engineer. Be a project engineer in your profession. We would like for you to go over to the side right now and hit that subscribe button. And then also, after you hit that subscribe button, go on over there and look at one of the 2 videos that you can look at next. They'll talk a little bit more about project engineering and project management. So until the next video, keep on growing as an engineer, keep on growing your management skills and developing your career as an engineer. See you on the next video.